Imagine an artificial intelligence network that doesn't belong to a company, a government, or a handful of corporations. Imagine a system where every computer, every programmer, and every researcher in the world can contribute power, knowledge, and creativity. That system already exists, and it's called Bittensor, TAO. To understand its magnitude, let's consider how artificial intelligence works today. Models like ChatGPT or Gemini are trained in gigantic data centers, with costs exceeding $10 million just for energy and hardware. Access is limited to corporations with infinite resources. The result? A centralized ecosystem where knowledge and power are concentrated in a few hands. Bittensor breaks that paradigm. Instead of relying on a single center, it distributes intelligence across a global network of nodes. Each node can contribute computing power, train models, or validate results. And the most surprising thing, the more valuable a node's contribution, the more rewards it receives in the form of TAO, the system's native token. Let's talk numbers. In 2023, the artificial intelligence market surpassed $240 billion, and according to estimates, could reach $1 trillion by 2030. If Bittensor manages to capture just 1% of that market, we would be talking about $10 billion moving within its ecosystem. The magnitude is hard to ignore. But Bittensor isn't just interesting because of the money. What's truly revolutionary is its decentralized architecture. Instead of relying on a company that makes decisions, the network is self-regulating. Each node is constantly evaluated. If its contribution is useful, whether translating languages, analyzing medical data, or processing images, it gains greater recognition and more rewards. It's pure digital meritocracy. The comparison to Bitcoin is inevitable. In 2009, a decentralized financial system seemed absurd. Today, the crypto market exceeds $2 trillion. Bittensor could be the same story, but with artificial intelligence instead of money. And here's the most fascinating thing. Each node not only contributes to a model, but also connects with thousands of other nodes, forming a collective digital brain, an organism that grows, adapts, and learns. Something that recalls the early years of the internet, when few could imagine that a network of computers would end up connecting more than 5 billion people. The question, then, is inevitable. If the internet connected the world's information, could Bittensor connect the world's intelligence? The truth is that the first signs are already here. Thousands of active participants, a token limited to 21 million units, and a vision that challenges the way we understand artificial intelligence. But how does it actually manage to coordinate so many nodes, guarantee quality, and keep the network running without a central control? That is the true secret of its design. But what really differentiates Bittensor from any other proposal in the world of artificial intelligence? The answer lies in its incentive architecture. In the traditional AI ecosystem, large models are controlled by companies that accumulate millions, even billions of dollars in investment, but restrict access to those who can pay for it. In contrast, in Bittensor, the engine is open and rewarded collaboration. Every time a model provides useful answers, it receives TAO tokens as a reward. This creates something never before seen: a global knowledge market in real time, where minds, both human and artificial, compete and cooperate at the same time. Imagine a kind of Wall Street, but instead of stocks, what is traded are answers, predictions, and algorithms. The numbers are impressive. Today, the network already has thousands of active nodes distributed in more than 50 countries. Every day, they process millions of requests ranging from automatic translation to medical data analysis. And all this without a central server that can fail, be censored, or manipulated. The comparison is inevitable. While platforms like OpenAI or Google Cloud concentrate 100% of the control in a few infrastructures, in Bittensor, security and stability increase with each new participant who joins. It's the difference between relying on a walled castle versus an infinite network of interconnected villages. And this model is not just theory. Concrete cases are already being seen. Startups that use the network to train virtual assistants specializing in rural medicine, where data is scarce and fragmented. Researchers who, without access to supercomputers, use Bittensor to test real-time climate prediction models. Even universities that use it as a global AI laboratory, allowing their students to experiment with algorithms that would otherwise be unattainable. The multiplier effect is brutal. Each new node not only strengthens the network, but also increases the value of the others. It's the same principle that made the internet great in its early days. The more connections, the more utility. And here appears the economic element that excites investors. The TAO token is not just a reward, it's the fuel that drives all this machinery. Those who contribute get TAO. Those who want to access the collective power of the network pay in TAO. And as demand grows, the token becomes an increasingly valuable resource. In short, we are witnessing the birth of a parallel economy of artificial intelligence, open, expansive, and without borders. But the big question that arises is, what will happen when this model, instead of competing, begins to outperform centralized giants in scale and speed? The fascinating thing about Bittensor is not just its present, but the future it projects. When we talk about artificial intelligence, we usually imagine machines solving tasks, algorithms that analyze large volumes of data, or digital assistants that answer questions. But what is happening with this decentralized network goes much further. It is the construction of a global infrastructure of collective intelligence. Think about this. Each node in the network is like a neuron. Separately, it can perform a small task. But when thousands of these neurons connect and begin to interact, something more powerful emerges, a neural network on a planetary scale. What was once limited to Silicon Valley laboratories is now being replicated in garages, universities, and research centers around the world. The data is clear. In just 2 years, the network has multiplied its collective computing capacity tenfold. Training costs, which on centralized platforms can exceed $10 million per model, are drastically reduced when distributed among hundreds of nodes. This opens the door to projects that were previously unthinkable for independent researchers or startups without massive capital. It is a real democratization of the power of AI. We are no longer talking about a few people controlling the technological future, but about a global community that shapes it organically. The comparisons are inevitable. While on Amazon, Google, or Microsoft's cloud, an error can leave millions of users out of service. In Bittensor, the network continues to function even if a node fails. While a centralized model is subject to the decisions of a board of directors, here the evolution depends on the interactions of thousands of anonymous collaborators. While knowledge in private companies is enclosed in contracts and licenses, in this network it is opened and redistributed, growing with each contribution. But the true magnitude of Bittensor is revealed when analyzing its future applications. Imagine a health system where doctors in Africa can access, in seconds, the most up-to-date medical knowledge on the planet, without paying millions in licenses. Or an agricultural sector where farmers in Latin America receive climate predictions generated by collaboratively trained models, much more accurate than those offered by government agencies. Or even a globalized education where any student, from a remote village to a large metropolis, can interact with intelligences trained in multiple languages and disciplines. This is not a distant dream. The first projects are already being tested, and the results are so promising that even governments and investment funds have started to look at the network. The appeal is not only technological, but also economic. The artificial intelligence market, which already exceeds $300 billion annually, could experience a shift in power if decentralization prevails. Now, every innovation brings challenges. The first is scalability. Can the network continue to grow without losing efficiency? The second is regulation. Governments will want to intervene when they understand that knowledge, which was once centralized, now circulates freely in an open market. And the third is mass adoption. How to convince companies, institutions, and users to migrate from closed, reliable systems to an open model, still under construction. History gives us clues. 3 decades ago, many doubted that the internet could compete with large private networks. Today, no one can conceive of a world without the network of networks. Bittensor could be treading that same path. What now seems experimental, in a few years could become the backbone of artificial intelligence on a global scale. The symbol of this change is the TAO token. More than just a cryptocurrency, it's the key to this emerging economy. It's already traded on major exchanges, and its value reflects the confidence that the project will not only survive, but expand with strength. It's the common language that connects developers, investors, and users in an ecosystem that doesn't rely on permissions or intermediaries. Ultimately, what's at stake is not just the efficiency of a system, but how humanity decides to build its technological future. Will we continue to trust a few corporate giants to control the planet's intelligence? Or will we take a leap toward a decentralized, collaborative, and open model where every contribution counts and every node adds value? The debate is open, but the trend is clear. Decentralization is advancing. And on that path, Bittensor has become a reference point, a living laboratory where we can see what the future of artificial intelligence could look like. What's fascinating is that this future isn't being written by a select few in closed offices. It's being written in real time, on thousands of computers distributed worldwide. Every new connection, every data contribution, every shared algorithm is another brick in the construction of this new digital tower. The outcome is not yet written. But one thing is certain. We are witnessing the birth of a technological revolution that could redefine access to knowledge in the 21st century. A network that turns intelligence into a shared asset, where we can all be part of the creation, not just spectators. And perhaps in a few years, when history remembers the beginnings of decentralized intelligence, the name Bittensor won't just be a project, but the starting point of a new technological order.